Picture a stone wall, water backed up behind it, and beneath that wall thousands of small silverfish packed so tightly against each other that the surface looks like it's boiling. They can't go over. They can't go around. So they wait there, gasping, until the water runs out of oxygen and they start to die in place, hundreds at a time, in a stream you could jump across. Now picture that same stream, decades later, wide open, cold, and moving, and 500,000 fish swimming straight through it every spring like the wall was never there. Both of those things happened on the same half-mile of water in Plymouth, Massachusetts. This is a story of how a run of nearly 2 million fish collapsed to almost nothing, and how it came back. Start with the fish itself, because almost nobody outside New England has ever heard of it. It's called river herring, and that name covers two nearly identical species, the alewife and the blueback herring, that run together in the same streams every spring. They are small. A grown one fits in your palm. Silver-sided, a dark smudge behind the gill, nothing that would ever get mounted on a wall or brag about at a boat launch. In fishery science, they are filed under a blunt category, forage fish. Their job, ecologically speaking, is to turn plankton into a body that something bigger can eat. Striped bass gather at river mouths to intercept them. Cod fed on them offshore for generations. Ospreys and bald eagles hunt them in the shallows. Otters and seals work the same spawning ponds. That's a lot of animals leaning on one small fish that most people can't identify. It also matters that river herring aren't a rare or exotic species dependent on some faraway habitat. They're an East Coast fish, running in streams from the Canadian Maritimes down to the Carolinas, and for most of American history they were about as ordinary as a fish gets, cheap, abundant, salted or smoked by the barrel, used as fertilizer and bait as often as food. That ordinariness is part of why almost nobody outside a handful of coastal towns noticed when the run started disappearing. There was no single dramatic event to point to, no oil spill or fish kill that made headlines. Just fewer and fewer fish showing up every spring, in river after river, until entire migrations that had run for thousands of years quietly stopped running at all. What makes river herring stranger than an ordinary bait fish is where they live, not one place, but two. Biologists call this anadromy. Born in fresh water, they migrate to the ocean to grow, then return years later to the exact fresh water where they hatched in order to spawn. That return trip matters more than it sounds like it should, because a herring that has spent 2 or 3 years in the Atlantic is, materially, made of ocean. Its fat, its muscle, its eggs are built for marine food. When that fish swims up a coastal brook and either spawns or gets eaten along the bank by an eagle or an otter, that ocean-built energy stays on land, in the soil, in the pond. Multiply that by hundreds of thousands of fish every spring, for thousands of years, and you have a river acting like a pump, pulling the wealth of the sea uphill into the forest. This is also why ecologists tend to describe river herring as a keystone species rather than just one prey item among many. A keystone species isn't necessarily the most abundant or the most visible animal in an ecosystem. It's the one whose disappearance causes a disproportionate collapse elsewhere. Pull river herring out of a coastal watershed, and it isn't only the fish that vanish. Striped bass have less reason to stage at river mouths in spring. Ospreys and eagles lose a reliable, predictable food source at exactly the time of year when they need one most, while raising chicks. The nutrient pulse that used to move from ocean to forest every spring simply stops arriving. None of that shows up as dramatically as a single collapsed population number, but it shows up in fewer birds, thinner forests along the banks, and a food web with one of its support beams quietly removed. That relationship is old. The Mashpee Wampanoag and their ancestors have lived alongside these runs for something on the order of 12,000 years, timing planting, fishing, and the turn of the calendar to the fish coming home. In 1620, when the ship known as the Mayflower brought a group of English colonists ashore in a harsh, unfamiliar place, the colony nearly didn't survive its first winter. The following spring, a Patuxet man named Tisquantum, remembered in most accounts as Squanto, taught the colonists a planting method rooted in Wampanoag practice, burying a herring alongside a corn seed, so the decomposing fish would feed the soil. That first harvest, the one now remembered as the origin of Thanksgiving, ran on a stream in Plymouth called Town Brook, the same stream, by name, that sits at the center of this story. For roughly 15 years after that, Town Brook kept doing what it had always done. Then, in 1636, Plymouth's colonists dammed it to power a grist mill, the same site where a working historic mill still stands today. That single decision set the template for the next 2 centuries. New England's industrial economy ran on falling water, sawmills, textile mills, ironworks, paper mills, and nearly every stream in the region with a usable drop in elevation eventually got a dam of its own. By the height of that era, Massachusetts alone held more than 3,000 dams, which meant a river running freely from its headwaters to the ocean without a single wall interrupting it, had become the exception rather than the rule. A dam does more than block a single migration. It changes the physical character of the water behind it. Moving water stays cold and holds oxygen well, scouring the stream bed clean as it goes. Water backed up behind a dam does the opposite. It slows, warms in the sun, and loses oxygen, while sediment settles over gravel that fish need for spawning. A river broken into a chain of small, stagnant impoundments isn't just harder for a fish to pass through. Large stretches of it stop functioning as living river habitat at all, even in the sections where fish could technically still swim. A river herring has no ability to reroute itself around an obstacle, no matter how the water around it has changed. Its migration is fixed to one exact pond, encoded by however it first imprinted on that water as a juvenile. A dam doesn't inconvenience that instinct. It simply ends a trip. The consequences show up starkly in the actual counts kept over the following decades on rivers across the region, runs that had once been documented in the hundreds of thousands, or in some cases millions, collapsed to a small fraction of that within a matter of decades, as generation after generation of fish reached a wall they couldn't climb and never made it back to spawn. It got bad enough that in 2006 Massachusetts made it illegal to catch, keep, or sell river herring anywhere in the state, a total harvest ban, driven by the recognition that the population had fallen too far for any take to be sustainable, even incidentally. Town Brook itself, the brook that once fed the first Thanksgiving harvest, was down to 6 dams and barriers along a run of roughly 1.5 miles, and its herring numbers had fallen from an estimated historical capacity near 1 million fish to around 150,000. Before anything else changed, people tried the most direct fix available. They carried the fish over the walls by hand. For years, staff from the Massachusetts Division of Marine Fisheries and volunteers went out in the cold, early spring mornings, scooped herring by the bucketful out of the water pooling below the dams, and physically carried or trucked them past the barriers so they could reach spawning habitat upstream. It worked, in the sense that it kept a run alive that might otherwise have blinked out. But nobody involved believed bucket brigades were a permanent answer. They were treating a symptom while the actual obstruction stood exactly where it always had. So Plymouth tried something Massachusetts had never done before, removing a dam specifically to help fish, rather than because the dam had failed or become a safety hazard. In 2002, crews took out the Plimco Dam on Billington Street, a structure that had already fallen into disrepair and no longer served any real economic purpose, and restored the natural stream channel behind it, letting a pond that had sat flat and stagnant for generations start moving again as a river. That project became the first proactive coastal dam removal in Massachusetts history, meaning the first time the state removed a dam purely to restore fish passage and river habitat rather than for safety or structural reasons. The response from the herring was immediate, and it didn't take years of gradual habituation for the fish to find a new route. They used it the first spring it was open. Later monitoring backed that up with real data rather than just observation. Pit tag studies run jointly by UMass Amherst, the U.S. Geological Survey, NOAA, and the town of Plymouth tracked individually tagged fish through different sections of the brook and found that once a stretch of river was fully restored and opened, roughly 96% of migrating herring passed through it successfully, compared to a much smaller share managing the same distance through the narrow fish ladder that had been built around a still-standing dam nearby. That gap wasn't speculation or a hopeful estimate. It was measured, tagged, and tracked, fish by fish, and it gave Plymouth's restoration team hard evidence that removing the barrier entirely worked far better than trying to engineer a narrow passage around it. That result set off what people in Plymouth now describe as a kind of chain reaction. Over the following 17 years, the town removed dam after dam along Town Brook, working with NOAA, the U.S. Fish and Wildlife Service, and the Massachusetts Division of Ecological Restoration. Each project brought its own complications, and none of them were simple. Some required clearing out contaminated sediment that had been settling in old mill ponds for a century or more. Others involved daylighting sections of the stream that had been buried entirely in underground culverts beneath old mill buildings, meaning crews had to demolish coal storage buildings and abandon mill structures just to bring hidden sections of the brook back into the open. Bridges had to be rebuilt, roadways reworked, and stream channels reconstructed by hand to mimic the natural riffles and gravel beds herring need for spawning. In 2019, on Earth Day, the town removed the Holmes Dam, the barrier closest to the historic mill site at the heart of Plymouth, and effectively completed the Town Brook restoration program almost exactly 400 years after the Mayflower's arrival in the harbor nearby. With 4 dams removed, 2 fish ladders improved, and 1 additional dam lowered, officials estimated the restored run could eventually support upwards of 500,000 fish, with unassisted access reopened to roughly 269 additional acres of spawning habitat that herring simply could not reach before. As of the most recent restoration work, only a single barrier remains on the entire stream, the Jenny Pond Dam, which dates back to that original 1636 grist mill site and still anchors a working historic mill today. Rather than remove it outright, the town has been engineering a nature-like bypass channel around it, designed to let both river herring and other fish, like trout, white suckers, and American eels, pass freely while preserving the mill itself as a historic landmark. Town Brook wasn't an isolated case, and this is the part worth being careful about, because the recovery across New England has been real but uneven. Some rivers rebounded strongly, others have moved much more slowly, and no one working on these projects claims the fish are fully out of danger. On the Mystic River near Boston, a watershed that runs through some of the most densely populated and industrialized towns in the state, the herring run has climbed substantially over the past several years. In 2024, more than 640,000 river herring passed through the fish ladder at the Mystic Lakes Dam in Medford, according to the official estimate from the Massachusetts Division of Marine Fisheries, the largest river herring run recorded anywhere in the state that year, and the highest count in that watershed since 2019. Volunteer monitors accredit much of the rebound to a fish ladder installed at Mystic Lakes Dam in 2012, which expanded access to breeding habitat, combined with a strong spawning year in 2019 whose offspring are now old enough to return and spawn themselves. The following year, in 2025, that same run climbed even further, to an estimated 815,000 fish. So here's a genuine question for the comments. Is there a herring run, a fish ladder, or a restored brook anywhere near you? Massachusetts isn't the only place this is happening, and it would be worth knowing how many of these rivers have quietly come back to life. And if a story like this is worth your time, there are a lot more of these small, overlooked recoveries still waiting to be told.